Alright, so we're going to be looking at part A from question number 2 from the most recent test. Now in this part, we have a plastic cube A which has a net positive charge, a neutral block B, and then we have C which also has a positive charge. A and C are made out of plastic and B is made out of copper. Now in this problem we want to find out how the metal copper block B gets polarized as a result of A and C. Now we know because the block B is made of copper that the net charge is going to be on the surface. This is the property that all metal conductors have. We also know that negative charges are going to want to move towards the positive charge, and positive charges are going to want to move away from the positive charges. So at first glance, we may be tempted to draw charges like this, and these being our negative charges. The only problem is, if we're doing this, where are our positive charges going? Well, let's not overthink this. Positive charges are going to move as far away as possible, and the only way they can do that is to move along the borders, like so. And this will happen on both sides of the block. So this is how the diagram should look. Now let's address some places where you might mess up if you misunderstand some of the concepts. So let's get rid of our lines. Alright, one mistake it's easy to make is to assume that because there are two positive charges on either side of the block, that there's going to be no polarization of the copper block. If you're thinking of the problem like this and you're thinking of the copper block as if it were an insulator, we have to remember because in metals the charges or the bonds are kind of mobile. There's almost like a sea of electrons. Electrons can move a lot more freely, and because of that, it makes a lot more sense for the negative charges, the electrons, to move to the sides, and for the positive charges to move to the top.